Welcome to the McMaster Manufacturing Research Institute. This is the Machining Systems Lab. Here we study machining processes on industry scale equipment, and we're largely looking at tooling issues here in our lab. So if you think about this large scale machine, it really comes down to the tooling that has a big impact on productivity, quality, and cost. So some of the things that we do here is we instrument the machine so that we can make more accurate measurements on the process and then work to try to optimize the process to improve it. And I think the main impact here is trying to look at the competitiveness of Canadian manufacturing industry. This is one of our high-speed machines. We're focused on making small components. We're looking at optical devices, optical grade surface finishes, as well as small biomedical type devices. We also have a lot of activity in the large-scale mold die as well as aerospace industry. So again, we're looking to machine high-performance alloys for the aerospace sector. We also have a new machine that was just recently donated to us by Moriseki, and here we're developing tooling paths and machine programs for high-efficiency CNC machining. We also have a lot of activity going on related to coolant development. We're looking to try to improve machining processes, and we have a number of different strategies that we're developing here. So here we're actually developing the tooling that goes into the other machines. So in this machine, we're developing custom geometry and novel cutting-edge features that allow the tools to be much more efficient in their operation. The big component here is trying to match the tool up with the process. So here in Canada, we need to be focused on high value added or high volume. But both of those demand a lot from their tooling, and we're trying to develop tooling that meets the specific needs of a process. We're also very actively developing full processes. So if we want to make Canada more competitive, we need to be able to focus on high value added components and be able to make them in such a way that incoming stock gets processed and final parts come out fully completed, labeled, and ready to be shipped for further processing. We're also putting a lot of focus on the physics of machining processes. As we're developing models of these processes, we need to go in and validate those models. So this piece of equipment is instrumented again to be able to make measurements that allow us to correlate that with our models that we're developing. So an excellent learning opportunity for the students is to develop a race car. So here we have the Formula Hybrid Teams car, and they have an opportunity to design a car from scratch and produce a lot of the parts here in the lab and see them ultimately end up in a car and then on a racetrack performing. So it's an excellent opportunity for students to relate design right through to manufacturing and final performance of the vehicle.